And now we'll go ahead and take the derivative. Okay? So a prime of x should be, the derivative will bypass the 2, and I take the derivative of 400x minus x squared, I'll get 400 minus 2x. 400 minus 2x equal to 0. I've got another factor of 2 in here I don't really need now. I'm going to factor it off. So this will become a 4, and I'll be left with 200 minus x equals 0. So x is obviously 200. All right, so we have one critical value. Making a sign chart for the critical value. So in theory, you have a whole number line here, right? If you're just looking at this equation or this function in theory, right, there's nothing that's restraining x from being any particular real value. But x does represent an actual physical measurement of a fence. So therefore, like in the last problem, we should truncate this at 0. All right, so we put the value 200 on here. I'll take a test case of 1. When I put 1 into the derivative, 400 minus 2, or 200 minus 1, however you want to look at it, that's certainly positive. Times a positive out here is positive. So the first derivative is positive on the left of 200, between 0 and 200. And once I pass 200, clearly 200 minus something bigger than 200 is negative. Times a positive remains negative. Okay? So now we know that this is a relative extreme location. Right? The derivative had a horizontal tangent here at 200, and at the same time we were increasing towards that point and decreasing after. So again, that's the essence of the first derivative test. So whatever, what are we going to test right here? So now we know that this is a relative extreme location, but we also know it's an absolute because all the function did from 0 onwards was go up towards the 200 location and down afterwards. So this must be the highest point across this entire interval. So this is now an absolute max at x equals 200. So the area function has an absolute max at x equals 200. All right, so it looks like the problem is basically solved. If x is 200, all we need to do now is go back and find y. Okay, so like I mentioned in the example before, usually you have that solved for somewhere, and there it is, right? Y equals dependent upon x over here. So if x is 200, y will be 800 minus 2 times 200, which is 400. Yeah. So the dimensions are 200 by 400. Dimensions of the pin with maximum area is 200, what do we measure in? I thought it was meters. No, it's feet. Right? The original was 800 feet of fencing. Right? So this is some number of feet going around here. Then x and y are measured in feet. So the dimensions should be 200 feet by 400 feet. So like I said at the beginning, this did not end up being a square. It wasn't that perfect equal length shape, right? But it ends up being a rectangle which is not a square. So it's a 200 for x, a 400 by y. And you'll notice here they did not ask you for the actual area, which was maximal. If they had asked you for the maximal area itself and not just the dimensions, you would just simply multiply 200 by 400 and get them the area. Just make sure you read and actually see what is they really want here. And it says just the dimensions of the pin. So we have given that to them with the 200 by 400 answer.